Good morning, students. Today we will discuss about basal metabolic rate. So, basal metabolic rate. What do you mean by basal metabolic rate? Means the rate of metabolism which is taking place in resting conditions is called basal metabolic rate. In this class, we will see the introduction, definition for BMR, measurement of BMR, that is how BMR is determined, and normal values of BMR. BMR is nothing but the abbreviation form for basal metabolic rate. Next, what are the factors affecting BMR? What are the factors affecting the BMR? We will discuss. Coming to the significance. So, in the introduction, we will discuss about the definition of BMR, measurement of BMR, normal values of BMR, factors affecting BMR, significance of BMR. Coming to the introduction, food is the fuel source of the body. Food is the fuel source of the body. And the food we ingested undergoes metabolism to liberate energy. This energy is utilized by the body to perform normal activities. The activities requires energy. So, coming to the basal metabolic rate, which is represented as BMR. So, BMR is defined as minimum amount of energy required by the body to maintain life at complete physical and mental rest in a post-absorption state. So, BMR is the amount of energy required by the body to maintain life at complete physical, mental rest conditions. And the subject should be in the post-absorptive. Several functions within the body occur at the basal condition. Several functions will occur in our body at basal conditions. So, what are those functions means? Working of heart, several. Now, coming to the measurement of BMR. BMR can be measured by apparatus called Benedict-Roth apparatus, which is a closed circuit device. BMR is measured by Benedict-Roth apparatus, which is closed circuit device, or by Douglas back method, which is a open circuit device. So, BMR can be measured by closed circuit device and open circuit device. The closed one is the Benedict-Roth, which is widely used, and the open one is the Douglas method. So, in this, what's happening means, first the subject should be aware. Subject means the person whose BMR is to be determined. So, the subject should be aware. He should be at both physical and mental rest conditions, and he must be in the post-absorptive state. What do you mean by post-absorptive state? Means he should be fasting for 12 hours. 12 hours. So, this is the Benedict-Roth apparatus. So, first here a mouthpiece is kept for the person. So, a mouthpiece is kept to the mouth, and then valve is open and oxygen is supplied. Next, a spirometer chamber is present. And valves are present for inlet and outlet adjustment. A rotating drum is there, which rotates. And next, a moving pin is present. So, this is the Benedict-Roth method. So, what's happening in the Benedict-Roth method means the volume of oxygen consumed by the subject, for a period of 2 to 6 minutes under basal conditions is determined. So, in Benedict-Roth method, the volume of oxygen consumed by a subject for a period of 2 to 6 minutes under basal conditions is determined, and it is represented by capital E. The standard calorific values of 1 liter of oxygen consumed is 1 liter oxygen consumed is 4.825. It is the standard value, we have to remember it. The standard calorific value of 1 liter of oxygen consumed is 4.825. Next, heat produced in 6 minutes equal to, what is the amount of heat produced means? 4.825 into E. Therefore, we have to calculate heat produced in 1 hour. So, multiply that value into 10. So, amount of heat produced in 1 hour equal to 4.825 into 10. Then, the body surface area, which is represented by capital A, is given by a formula, that is capital A equal to height into 0.725 into subject's weight, capital W, into 0.425. Okay, H is the height in centimeters square, W is the weight in kg. So, body surface area equal to H. Body surface area A equal to H into 0.725 into weight into 0.425. So, this is the formula. Coming to the normal values of BMR. The adult man is having 35 to 38 calories per square meter per hour, which is equal to 1600 calories per day. Okay. For adult woman, the value is 32 to 35 calories per square meter per hour, or 1400 calories per day. So, if you see, adult man is having high BMR than adult woman. So, adult man BMR is 1600 calories per day and woman is 1400 calories per day. Coming to the factors, what are the factors affecting BMR? First one is surface area. The surface area is directly proportional to the body surface area. BMR is directly proportional to the body surface area. That is, if a person is having higher body surface area, then the BMR rate will be more. Second one is sex. So, if you compare BMR between men and women, men is having higher BMR. Generally, men are having 5% more BMR than women. Coming to the age, infants. In infants and in growing children, BMR is higher. Why? Means they are having more physical activity. They are doing more physical activity. In adults, the BMR value decreases at the rate of 2% per decade of life. That means for every 10 years, 2% of BMR is going to be decreased. Next, the third factor is physical activity. So, increase with regular exercise. So, if you are doing regular exercise, the BMR rate will be increased. Next factor is hormones. Mainly different hormones are present, among them thyroid hormone. So, thyroid hormone increases BMR. Next, epinephrine, cortisol, sex hormones and growth hormones increases BMR. So, these are the hormones. Generally, hormones will increase the BMR rate. Coming to the environment. So, our surroundings and environment will also influence the BMR. BMR is higher in cold climates when compared to warm climates. Next factor is starvation. During starvation, a decrease in BMR generally up to 50% has been reported. During starvation, the BMR rate was found to be decreased at the rate of 50%. Next factor is fever. So generally, in fever condition, BMR increases. Why? Means in fever condition, the metabolic rate is increased. So for every 1 degree rise in body temperature, nearly 10% BMR is found to be increased. 10% BMR is found to be increased. And next condition or next state is disease status. So disease conditions, during disease conditions, BMR is elevated. It is increased in infections like leukemia. Leukemia is nothing but WBC, increase of WBC cancer rate, cardiac failure, and during hypertension. So during diseased conditions like leukemia, hypertension, cardiac failure, the BMR was found to be increased. So these are the different factors affecting the BMR. So first factor is, the factors affecting BMR is, first one is age. Infants will have more BMR. Infants will have more BMR. Sex, man is having more BMR rate when compared to the females. Next, body surface is directly proportional to the BMR. A person with higher body surface will have higher BMR rate. Physical activity increases the BMR rate. Physical activity increases the BMR rate. Hormones like thyroid, epinephrine, etc. will increase the BMR rate. Next one is the climatic conditions. Climatic conditions. Generally, BMR is higher in cold climates when compared to the warm climates. Starvation. During starvation was found to be decreased by 50%. Next, fever. Fever increases BMR. For every 1 degree centigrade increase in temperature, 10% BMR will be increased. And during infections like leukemia, cardiac failure, hypertension, the BMR rate was found to be increased. Now we will see the significance of BMR. BMR is important to calculate the caloric requirement of an individual and planning of diets. So, by knowing the BMR of a person, we can design the diet plan and also the caloric requirement of that person. Next, by knowing the BMR rate, we can assess the thyroid functioning. BMR is below normal in starvation. That means BMR rate is decreased in starvation conditions, and during the undernutrition conditions, BMR rate was found to be decreased. And the BMR is above normal in fever. So BMR is above normal. That means the BMR rate is increased during fever, diabetes, insipidus conditions, leukemia, and polycythemia. So this is about BMR. BMR is nothing but basal metabolic rate. So by knowing the BMR, we can design a diet plan and how much calories are required by that person. And next, we can assess the thyroid functioning in that subject, and we can know the rate of BMR. So generally, in starvation conditions, the BMR will be decreased, and in disease conditions, the BMR rate will be increased. So this is about BMR. Next, we will see about specific dynamic action of food. Specific dynamic action of food. So coming to the specific dynamic action of food, it is also known as thermic effect of food. It is also known as thermic effect of food, which is represented as TEF, or dietary induced thermogenesis. Dietary induced thermogenesis, which is represented as DIT. So, specific dynamic action of food. Specific dynamic action of food is defined as amount of energy expenditure by above the basal metabolic rate due to the cost of processing food for use and storage. For the food use and storage. So, it is the amount of energy expenditure above the basal metabolic rate due to the cost of processing food for the use and storage. Heat production by brown adipose tissue, which is activated after consumption of a meal, is an additional component of dietary induced thermogenesis. Heat produced by brown adipose tissue, which is activated after consumption of a meal. Consumption of a meal is an additional component of dietary induced thermogenesis. Next, the thermal effect of a food is one of the components of metabolism along with the resting metabolic rate, and the exercise component. A commonly used estimate of the thermic effect of food is about 10% of one's caloric intake. The thermic effect of food is one of the components of metabolism along with the resting metabolism. For example, dietary fat is very easy to process and has a very little thermic effect, while protein is hard to process and has a much larger thermic effect. It has a much larger thermic effect. So, protein being hard, it has long time to digest. Therefore, the thermic effect, that is the SDA value of proteins, is high. Coming to the specific dynamic action of food. Rubber is a scientist who observed that carbohydrates, fats, proteins fed of fasting dog stimulated the energy metabolism over the basal level extends. So, what rubber did means, rubber is a scientist who observed that carbohydrates, fats, proteins fed to a fasting dog. So, fasting conditions is important. Stimulated the energy metabolism over the basal level to varying extents. For example, he found that in a fasting dog requiring 400 calories, feeding of 100 grams of carbohydrate produces 425 kilocalories. Generally, it has to produce 400 kilocalories, but it was found that it is producing 425 calories. That means 25 kilocalories extra amount of energy is produced, which is called the thermic effect of food. So, the extra heat produced is called as thermic effect. Next, the specific dynamic action of proteins is the highest, while that of carbohydrates, fats. So, it is generally 30% highest when compared to carbohydrates, fats. Next, the specific dynamic action of a mixed diet containing 0.25 grams carbohydrates, 10 grams fat and 10 grams protein is about 8%. So, a mixed diet containing 62.5 grams of carbohydrates, 10 grams of fat and 10 grams of protein is about 8%. A considerable amount of work has been carried by the scientists Lusk and several other workers on the causes of high SDA value of proteins. That means the scientists Lusk and his co-workers worked to find what is the reason for higher specific dynamic action of proteins. They identified two reasons. So, the two main factors responsible to high SDA of proteins are, first one, The energy required for deamination of amino acids, which again is derived by the oxidation of the other metabolites. The energy required for the deamination of the amino acids, which again is derived by the oxidation of other metabolites in the body. The second reason is the energy required for the synthesis of urea. The energy required for the synthesis of urea, which is obtained by the oxidation of other metabolites present in the tissues. So, because of these two reasons, the SDA value of proteins was found to be higher when compared to other. So, this is about specific dynamic action of food. So, in this session, we have seen the basal metabolic rate, factors affecting basal metabolic rate, significance of basal metabolic rate, and next specific dynamic action of food, and what is the reason for having proteins higher SDA values than other food. So the main reason is two. One is deamination. The energy required for the deamination of amino acids is given by, or it is again derived by the other metabolites in the tissues. So thank you for this